Hello everybody. This is going to be the video to finish up the immune system. I'm going to go by pretty quickly because I want to make sure that you know exactly only what you need to know, and we can skip the things that are extra that for now you don't need to know. All right, folks. My pen is not working, so I'm going to talk while it's pairing. So we've already covered our first line of defense and our second line of defense. So here we are on our third line of defense. Okay, now it's woken up. Good. We talked about in class the third line of defense is the only one that is specific, like the sniper or the hitman. It has responses that are all over or systemic, but more importantly, this is the only one that has memory. Okay. We're going to be focusing on the B and T cells. We did talk about self versus non-self, so I'm going to skip all that. And here's what I want to start with. For our third line of defense, we focus on B cells and T cells. Technically, they're lymphocytes. That's not as important. I mean, it is, but we're going to focus on B as in boy and T as in, I don't know, trail mix. I don't know. So here's a nice summary sheet, a summary slide to show the beginning basics. So check it out. We have more T cells. The majority of our lymphocytes are T cells. So we have more of the T cells, fewer of the B cells. How do they work? T cells are more common, and they directly attack the bad guys. B cells are a little bit less common, and they attack more indirectly. The B cells attack indirectly through antibodies. T cells attack directly. The last thing I want to point out is our T cells are going to usually attack more cellular, intracellular targets, whereas the B cells, extracellular. These are the key things to point out to begin with. All right, let's talk a little bit about T cells. What did we say about T cells? They're more common. They attack directly. What else did we say? They're more common, they attack directly, and they tend to attack cellular targets. There's a lot of information here that you don't need to know. I'm not going to ask you about the different types of T cells. There are some memory T cells, there's helper T cells, there's worker T cells. Due to time, we just want to focus on the basics. In addition to what I've already covered, the only thing I'd like you to know about T cells are the basic 2 steps. We present and recognize the foreign body, and then we activate the T cells to kill it. Be able to pick from a multiple choice list. If I give you a multiple choice list on our next exam, which of the following describes how T cells work? You would choose the option that includes these 2 or something to that nature. I get more specific. You don't need to know all those specifics. Okay, let's go to B cells. A reminder, we talked about B cells being less common, and they work indirectly through antibodies, and they're active against more extracellular target. Okay? And just like I said for the T cells, I'd like you to be able to recognize from a list the basic 3 steps of the B cells. Exposure and matching, differentiation or cloning of B cells, and then production of antibodies to kill them. These are the 3 basics. We match the antigen and antibody. We differentiate, you might see the word clone B cells. We actually clone them into plasma cells. So the key words for B cells, 3 steps. T cells only had 2. Be able to pick from a list. B cells, they match with the antigen antibody. The B cells clone and differentiate into plasma cells. And then we produce the antibodies that actually do the killing. Be able to pick from a list. You don't need to know the specifics about the antibodies. I give you some information about them, but you don't need to know them. To end this chapter, we're going to talk about immunity. So this can be tricky. Please take your time. To understand immunity, let's first define active versus passive. So as you're studying, I think a good way to start would be to first memorize what active versus passive means. Active means that the body produced the antibody. With this kind of immunity, we tend to be talking about B cells, which means antibodies. So when we say active, the body itself made the antibody. If I'm exposed to chickenpox virus and my body makes the antibody to protect me against it, that's an active immunity because I made the antibody. If it's passive, outside antibodies were given. Think about a pregnant woman passing antibodies to a fetus in her body. The fetus itself didn't produce the antibodies. They were given passively. This is active versus passive. In terms of antibodies, if it's active, the person themselves made the antibody. And when the person makes the antibody, this is when we have memory. Passive means that the antibody was given from the outside and there's no memory. So as you're reviewing, please start there, defining active versus passive. Next, we're going to define natural versus artificial. Okay, separately. We're going to put it all together in a moment, but just memorize them one at a time. If it is natural, it means, natural means that you were exposed in a non-deliberate way to the virus or bad guy. This would be like chickenpox that I encountered from the air. It was not on purpose. Natural means I was exposed to the bad guy in a non-deliberate, non-purposeful way. Accidental, you might say. Artificial means it was a deliberate exposure to the bad guy, like a vaccine. When you get a vaccine, they purposely inject you with a little bit of the virus. That's what a vaccine is, folks. When you had to get vaccines to go to school in the first place, there's probably a measles, mumps, rubella, MMR vaccine. The vaccine is a tiny amount, just enough of the actual virus to cause your body to generate the antibodies so you'll be protected. That exposure is artificial. It was an artificial or deliberate exposure. Whatever works for you, artificial. Natural means that it was an accidental, non-deliberate, natural exposure, like I just encountered the virus in the air. That's natural. Artificial means that you purposely were exposed to the bad guy, like through a vaccine. That's my suggestion for how to study. First, memorize active versus passive. Then, memorize natural versus artificial. Now we can put them all together. I would like you to be able to give an example of each. Natural active immunity is like producing an antibody after exposure to chickenpox. You can use any example that you like, but this would be like, as a kid, you were exposed to chickenpox virus in school, so your body actively made the antibodies, and it was a natural, non-deliberate exposure. What is an example of artificial active vaccine? The exposure was artificial. You were given or exposed to the virus through an artificial way, but it was an active, still active. You made the antibodies yourself. Both of the first two would give you memory. Because it was an active, you produced the antibody yourself. The other two examples I'd like you to know: natural passive, antibodies given to fetus from mother. It's a passive way. The antibodies were not made by the fetus. They were given from another source. And it's natural because it was a natural exposure. Artificial passive would be like an antivenom. What if someone is bitten by a poisonous snake? If you have a poisonous snake bite, do you want to wait for your body to make the antibodies on its own? No, because that's poison. So this would be when you go to the ER or go to the doctor and they give you the antibody. That's why it's considered passive, because you're given the antibody, and it's artificial because it came in a needle. Be able to give an example of each. Okay, the rest here would just be some quick points. What I want to say is your immune system is always working. So sometimes we tend to think that our immune system is only working when we have symptoms. Like you hear me blowing my nose, right? I'm having an allergic response. That's an obvious way to hear or see that the immune system is working. But your immune system is still working in some way, even if you don't have symptoms, right? So even when you're otherwise healthy, we do rely on our immune system to be doing some level of work to get rid of bad guys. When do we actually get sick or show symptoms? So it's like a race, right? That's why I have this picture. We only get sick when our immune system's ability to fight can't keep up with the amount of bad guys. So I just wanted to make that point. It's always working. We only show symptoms when our immune response is no longer able to keep up with the bad guys that are currently invading. Be able to give an example of an autoimmune disease. We talked about this in class. This is a disease where your body is not able to differentiate self from non-self, and the body starts to attack its own cells. Rheumatoid arthritis is when your body attacks its own joints. Not because there's actually anything wrong with your joints, but because there's something wrong with the immune response and your immune system thinks something that's healthy is not. And then an immunodeficiency would be like HIV and AIDS. This is where the illness or disease actually targets the immune cells. So I think I mentioned this, HIV and AIDS breaks down and kills our natural T cells. So someone that dies from HIV or AIDS, well, they would die from AIDS. Hi, Kat. All right, Kima's making an appearance. Someone that dies from AIDS doesn't die from AIDS. They die from a common cold because the AIDS has killed a lot of their T cells. So they're no longer able to protect themselves. Okay, Kima, we hear you. The whole class hears you. They die from a common cold because they no longer have enough of the immune cells to take care of it. All right, that's the end of this. Good luck studying. If you have any questions, let me know.